excuse me, we spent quite a bit of time in 1.2, a little longer than I was wanting to, but let's go ahead and move on to 1.3. Spend a little bit of time in 1.3 as well. 1.3 is talking about properties of real numbers. When I say real numbers, that's just a set of numbers. We've got multiple different types of sets of numbers. We've got integers, we've got the set of whole numbers, we've got the set of real numbers, and all sorts of other types of numbers. In Algebra 1, we're mainly going to deal with real numbers, integers, whole numbers, stuff like that. Okay? So, there are several properties of equality that apply to the addition and multiplication of real numbers. So today, we're going to dig real deep into all these properties of equality of our addition and multiplication of real numbers. So, lots of notes today, lots of information. That's okay, we'll get through it together. Here are our first three properties of equality. I'm going to kind of go a little quickly through these. These are in your textbook if you need to write these down later if you don't get all of them. Okay? I don't know the exact page number, but it's the very beginning of 1-3. So the first property is the reflexive property. Any quantity is equal to itself. Hopefully that one's pretty straightforward. Essentially, any number is equal to itself. For any number A equals A. Some examples they give are 3 equals 3. 3 equals itself, right?
Right.
Right? Yeah. 9 plus 2 is equal to 9 plus 2. Those are the same two numbers being added together. They're going to create the same number. That number equals itself. Any questions on the reflexive property? Like I said, I feel like that one's pretty straightforward. If you have a number, it's equal to itself. Okay? Next, we have the symmetric property. If one quantity equals a second quantity, then the second quantity equals the first. So for any numbers A and B, if A equals B, then I know that B equals A as well. So if I have 7 equals 3 plus 4, then essentially I can reverse that. Then I know 3 plus 4 equals 7. Essentially, we can write it forwards or backwards. Any questions on my symmetric property there?
No.
Thank you. Okay, the transitive property, the third one on the slide. If one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third quantity. So this one's kind of like a chain of events here. For any real numbers A, B, and C, if A equals B and B equals C, then I know that A also equals C. Does that make sense? So if 5 plus 1 equals 2 plus 4, and 2 plus 4 equals 6, then I know that this first one, 5 plus 1, equals this last one, 6. If A equals B and B equals C, then A equals C. Any questions on my transitive property?
No.
We okay there? So any questions on these first three properties of equality? Okay, like I said, I'm going to kind of move through these quickly. So if you want to be on page 23, that way you know where to get these. After we take the notes, you can go to page 23 in your textbook. So we got an example here. And it's going to pertain to these previous three properties we just talked about. It says, identify the property of equality used to justify each statement. Explain your reasoning. So it says, if 13 plus 25 equals 38, then 38 equals 13 plus 25. So, which property justifies this statement? If 13 plus 25 equals 38, then 38 equals 13 plus 25. Which of these three properties helps justify that statement on letter A?
Ref. Oh, wait.
Simple math.
Say it again.
How do you say it?
First, second, or third?
Second.
Second, yeah, symmetric, right? Everyone say symmetric.
Symmetric.
Symmetric. So, part A, I would put, golly, can't write. Symmetric property. It's asking for the property of equality that helps justify this statement. Any questions on letter A? Letter B. Y plus 4 equals Y plus 4. Y plus 4 equals Y plus 4. So which of these properties helps justify that statement? Y plus 4 equals Y plus 4. Reflexive, right? Any quantity is equal to itself. Here, it's saying Y plus 4 is equal to itself, right? Because it's the exact same thing written on both sides of the equation. Any questions on examples 1, A, or B? We okay with those two? Okay. Example 2. Interpret properties of equality. If the amount of sugar in a recipe is equal to the amount of flour plus 2 tablespoons, and the amount of flour plus 2 tablespoons is equal to the amount of milk, then the amount of sugar is equal to the amount of milk. So, I don't think I have the directions written here. Let me find the directions in the book. Oh, yes I do. Letter A wants us to write an expression in the spaces below given this statement up here. So it says if the amount of sugar in a recipe is equal to the amount of flour and 2 tablespoons, and the amount of flour and 2 tablespoons equals the amount of milk, then the amount of sugar is equal to the amount of milk. So essentially, let's go ahead and assign some variables to these things. So kind of think like A, B, and C here. What variable do you want to assign to sugar?
S.
A? Oh, I heard S. Let's stick with A, B, and C for right now. Let's make sugar A. What do you want to make the amount of flour in 2 tablespoons? B. So here we're saying A equals B, right?
Sir.
Okay. I've already got a variable for this. What's the variable for this? B. Do I have a variable for milk yet? What do we want to make it? C. So here I'm saying A equals B and B equals C. What's the variable for sugar? A. The variable for milk? C. So I can essentially build my expression. A equals B and B equals C. Then A equals C. Which property is this that we talked about earlier?
Transitive.
What?
Transitive.
It's our transitive property, right? If one quantity equals a second quantity, and the second quantity equals a third quantity, then I know that the first quantity also equals the third quantity. And here it is right here. If A equals B and B equals C, then I know A equals C, which is exactly what we have written here, correct? So here's my expression right here on letter A. Letter B is asking us, the statement is an example of which property of equality. We just answered that. That would be our transitive property. I think the main thing here they're wanting you to recognize is that it was the transitive property. They had one thing equaling a second thing, the second thing equaling a third thing, meaning that, hey, that first thing's also going to equal that third thing. Okay? Any questions on example 2? We good there? And then, like I said, part B, this is an example of our transitive property. Example 3. I forgot to put the directions on here, but it says use the given property of equality to complete each statement. So letter A, it gives us the first part of our equation, y minus 21, and it tells us which property to use. Okay? So let's go look back at our 3 properties again. Remember, reflexive, a quantity equals itself, right? Symmetric, I can reverse the order of my equation. If A equals B, then B equals A. Transitive, if A equals B, B equals C, then A equals C. So, which property does it want us to use here? Reflexive. So if I go back to reflexive, it's any quantity needs to be equal to itself. So I need something to be equal to itself. So for letter A, what do I need to fill in the blank to make it the reflexive property?
Y minus 21.
Y minus 21, the exact same thing. So I want to say y minus 21 equals y minus 21. This quantity equals itself. We okay with that? Letter A. Okay. Letter B. If 24 plus 11 equals 9 plus 26, and 9 plus 26 equals Z, then 24 plus 11 equals blank. And it wants us to use our transitive property of equality. We just used the transitive property in our previous example, and this is the one that has 3 total quantities, right? If A equals B and B equals C, then I know that A equals C as well. So, knowing that information, what would I need to fill in for the blank here on this transitive property? Z. I know 24 plus 11 equals 9 plus 26. I also know that 9 plus 26 equals Z. So if you give these variables, this would be A, B, B, C. So I know that A equals C. My C value is just Z. Any questions on example 3 using our reflexive or our transitive properties of equality? A lot of your assignment is going to be doing just this. Either filling in a blank to make it true to that property, or telling what property describes the expression. A lot of your assignment is going to be a lot of that. Okay? Okay, you guys hopefully know this, but the sum of any number A and 0 is what? If I add 0 to any number, what do I get? That number. We're talking about addition here, right? If I add 0 to any number, I'm going to get that number back. So I'm adding nothing to it, right? So the sum of any number A and 0 is equal to A. Thus, 0 is called our additive identity. It's called the additive identity. If the sum of 2 numbers is equal to the additive identity, what is the additive identity? What's our additive identity? 0. Right? So if the sum of 2 numbers is equal to 0, like 4 plus negative 4, that gives me 0, right? That's my additive identity. Then those 2 numbers are called additive inverses of each other. Okay? So if I can add 2 numbers together and they equal 0, they are called additive inverses of each other. Everyone okay with that?
Yes, sir.
Okay. So, here's 2 more properties for you. 2 more addition properties. We've got the additive identity property, which is what we just talked about on the previous slide. For any real number A, the sum of A and 0 is A. So that's it written out in words. If you write it with symbols, A plus 0 equals 0 plus A, which equals A. And then some examples. 5 plus 0 equals 5. 0 plus 5 equals 5. 10 plus 0 equals 10. 0 plus 7 equals 7. If you add 0 to anything, you just get that number back. That's all that's saying. Okay? Questions on our additive identity. Okay, additive inverse. We also talked about this on the previous slide. A real number and its opposite. You guys understand what I mean when I say that? What's the opposite of 5? Negative 5. If I add those together, what do I get? 0, the additive identity. So in any real number and its opposite are what we call additive inverses of each other. A plus negative a equals 0. 2 plus negative 2 equals 0. Subtraction and adding a negative are the same thing. Okay? So I can have 7 minus 7 equals 0. Those are also additive inverses of each other. 12 and negative 12. Additive inverses. Any number and its opposite are going to add to give you 0. Any questions about that? The product, now let's talk about multiplication. We've talked about addition all the way up to this point. Multiplication, the product of any number a and 1 is equal to a. If I multiply any number times 1, what do I get? Huh?
Oh, the same number. That-
Itself, right?
Yeah.
3 times 1 is 3. 20 times 1 is 5 million times 1 is 5 million. Any number times 1 is equal to itself. So, earlier we had the additive identity. Here, 1 is called our multiplicative identity. Okay? Any time I multiply a number by 1, I get that number back. The product of any number a and 0 is what?
0.
0. 5,273,165 times 0 gives me 0. 1 times 0 gives me 0. Any number times 0 gives me 0. Product of any number a and 0 is equal to 0. This is called our multiplicative property of 0. Everyone say multiplicative. Multiplicative. It's fun to say. Two numbers with a product of 1 are called multiplicative inverses, or another word we can use for it is reciprocals. If I can take a number and multiply it by another number and get 1, they're called multiplicative inverses of each other. They're called reciprocals of each other. Okay? Any questions there? Can you guys read that? Tried to make it as big as I could. Here's 3 more properties. These are multiplication properties. We just talked about them on the previous slide. For any real number, a, the product of a and 1 is a. Anytime I multiply a number times 1, I get that number back. We good there? We good with that multiplicative identity property. Okay? Multiplicative property of 0. Anytime I multiply a number by 0, I get what? 0. Any number times 0 is 0. Any questions on my multiplicative property of 0? Okay, last one. This is our multiplicative inverse property. For every real number, a over b, where a and b do not equal 0, there is exactly one number, b over a, such that a over b times b over a is 1. So there's only one multiplicative inverse of every number. Meaning I can multiply it by that multiplicative inverse and get the number 1 back. So a over b times b over a equals 1. b over a times a over b equals 1. They're called reciprocals of each other. Okay? So, if I have 2 over 3, to get the multiplicative inverse of it, I just essentially flip the fraction. The numerator becomes the denominator. Denominator becomes the numerator. I multiply by that number. So what's the reciprocal of 2 over 3? 3 over 2. If I multiply 2 over 3 by its reciprocal, I get 1. Same thing, 3 over 2. Flip it, 2 over 3. Multiply those together, I get 1. Questions on these three properties? Okay, can I move on? Okay, now we got a few examples here using all this information we just talked about. I know it's a lot of information. It says evaluate 4 minus 2 squared plus 8 times 2. Evaluate 4 minus 2 squared plus 8 times 2. So, talking about order of operations, what would you guys do here first? The exponent, right? There's no parentheses with property or I can't think of the word. Any operations going on inside the parentheses. So let's go ahead and do our exponent. What's 2 to the second power? 4. Everything else just comes down and stays the same for now. Okay. What would you do next? Multiplication. What's 8 times 2? 16. What would come next? The subtraction or addition?
Left to right.
Left to right. Addition and subtraction are lumped together. So I do it all from left to right. What's 4 minus 4? 0. Now, when we get to this part of the problem, 0 plus 16. This is our additive inverse property. Anytime I add 0 to a number, I get the number, right? So 0 plus 16 gives me 16. Does everyone see how that's my additive inverse property? I add 0 to a number, I get that number back. So it'd be 16 here. Questions on example 4? Example 5. Evaluate 3 over 2 times 2 over 3 times 7. If we're using the order of operations, I only have multiplication here, so I'm working left to right, correct? Does anyone notice anything about my first two numbers? Say it again. They're inverses of each other. Multiplicative inverses. What does that mean? Do what? What happens when I multiply them? If I multiply a number by its reciprocal or its multiplicative inverse, it equals 1, right? If I have 3 times 2 and I'm multiplying by 2 times 2 over 3, it's going to give me 1. So that's one of my properties right there. A multiplicative inverse property. Now, this is another one of my properties. This is my multiplicative identity property. Any number times 1 gives me that number. So what's 1 times 7? 7. Does everyone see how these properties are applying to each of these problems? Each time we simplify it a little further, we get another one of our properties. In this case, we had the multiplicative inverse and the multiplicative identity. Okay? Questions on 5? We good so far? This is my last example here. We've got the quantity of 4 minus 3 times 2 plus 7 times 0. The quantity of 4 minus 3 times 2 plus 7 times 0. Any ideas here? What? Say that again. Why do you say that? Very good. I don't really have to do a whole lot here. Okay? This is my multiplicative property of 0. This whole quantity at the beginning is all in brackets, right? And it's all being multiplied by 0. So, even if I did all this stuff first, I could do that if I wanted to. It's a little bit of unnecessary work, though, Because in the end, I'm going to get this down to one single number, right? I'm going to have that single number times 0, which is 0. So my answer is just 0 here. We okay with example 6? All right. We okay with today's notes? I know it was a lot of information, but you've got it in your textbook. You can get it written down in your notes, copied from the textbook. So yeah. I'm actually going to give you another online assignment. So disregard what this says up here. That's why I'm scribbling it out. It's going to be 1.3, homework number 1, MH. And I've got to go make sure it's published on Canvas before you guys get started. But we've got 20 minutes in here left. So you guys are going to have a decent amount of time to be working on this. Are there any questions about the notes before I end the recording?